Anyway, so just to talk a little broadly about space and where things are today. Obviously, US government manned exploration is not in a great place. We've got the 3 remaining shuttles are grounded. It looks like first flight might only be a year from now, if that. And we've got a vehicle that is incredibly expensive and really quite dangerous. It's, for reasons mentioned there, it's got a side-mounted crew compartment, so if there's an explosion, it's basically instant death. You've got solid rocket boosters, which once you ignite them, you can't turn them off. And there's something fundamentally dangerous about premixing your fuel and oxidizer, I think. And then you've got wings and control surfaces. When you re-enter, you've got to maintain a precise angle of attack. Even a momentary variance in that can break the whole vehicle apart. So, and then of course it's got no escape system. So if anything does go wrong, you're toast. And you've got a cost that is really pretty hard to fathom. The shuttle program, when you add up all the pieces, is about $4 billion a year. And so you can divide $4 billion by the number of flights, and that'll tell you what the cost is. And if there's, say, 4 flights a year, which they haven't been for a while, then you're talking about $1 billion a flight. The plans for the immediate future are obviously we've got to continue building the space station. So we're going to keep flying the shuttle, but I think it's probably going to be the minimum number of shuttle flights that we need to launch. The long-term plans are to build something called Orbital Space Plane. And I say plane in quotes because one of the options is a capsule. So it should be called maybe Orbital Space Thing. But the basic idea is to have something that's hopefully a little cheaper and a lot safer than the space shuttle. So in particular, it's going to have an escape system. So if something does go wrong, you can abort to safety. The downside is that while it might be a little cheaper, it's still going to be pretty darn expensive. The estimated cost per flight of orbital space plane is somewhere in the region of $300 to $400 million a flight. And of that amount, just $200 million alone goes to Boeing for the Delta IV Heavy expendable booster. It's a $15 billion development effort and expected to be completed in 9 or 10 years. Now, typically things have not been under budget and under time. So it's unlikely, I think, given historical precedent, that it will stay within $15 billion and the 2012 timeline. And a bit about what's going on elsewhere in the world. In Russia, the Soyuz is our only access to space station. It's considerably cheaper, considerably safer. The Soyuz has a very good track record. The crew is top-mounted. It has an escape system. There are no wings or control surfaces to go wrong. Overall, it's a pretty good system. And the estimated costs are about $60 million a flight, which is more than an order of magnitude less than the space shuttle. The thing that constrains them, obviously, is the weakness of the Russian economy. It's very hard for them to embark on ambitious programs with an economy the size of Belgium. So China is probably the most interesting thing that's going on in space. This month, China is expected to be only the third. It's expected to launch their first person into space. They'll make them only the third country ever to put someone in orbit. And they've put a lot of money and effort into this program. If anything serves as a spur for human space exploration, it is likely to be China's ambitions in space, and hopefully a sense in America that we want to at least keep up with China. And they have grand ambitions beyond just low Earth orbit. They're planning on setting up a space station, putting a base on Mars, and eventually sending humans to Mars. So what's happening in the US that I think might ultimately surpass all of that stuff is entrepreneurial space activities, where things are led by the spirit of free enterprise. And I think there's perhaps an analogy here where just as DARPA served as the initial impetus for the internet and underwrote a lot of the costs of developing the internet in the beginning. It may be the case that NASA has essentially done the same thing by spending the money to develop some of the fundamental technologies in the beginning, and then once we can bring sort of the commercial pre-enterprise sector into it, then we can see the dramatic acceleration that we saw in the internet. So there are several serious launch vehicle efforts underway. I'll talk about each one. There's Burt Rutan of Scaled Composites. Burt Rutan is one of the world's foremost aircraft designers, and he's developed a suborbital vehicle that they're actually flying out of Mojave. And this is an X-Prize class vehicle. There's John Carmack, who wrote Quake and Doom. He's probably one of the best software engineers in the world, one of the best engineers that I know, period. And he's developing a vertical takeoff and landing vehicle. Jeff Bezos, who I understand was here last week, is a huge space advocate. And it's my understanding that he intends to spend something on the order of $1 billion over the next 20 years on space exploration. And then my company, SpaceX. And I think within the next several years, these entrepreneurial efforts will actually be what drives space exploration.